The UK port industry is the largest in Europe, with millions of products travelling through terminals across the country every day. In 2013, UK container traffic rose by 3% to 21.4 million units. This growth is expected to continue well into the foreseeable future. With this demand for expansion, UK ports are reaching their maximum capacity, as well as showing a clear need for new facilities to handle the ever-increasing size of container ships. With vessels able to carry over 19,000 containers and with lengths of over 400 metres, the need for innovative new development with greater operational efficiency has never been higher. The format of this presentation will be as follows. First, the Vectura team will be introduced before a run-through of our proposed scheme. The detailed design and project deliverables will then be explained, followed by the project schedule, project risk assessment, project stakeholders, financial cost breakdown, and finally, our concluding remarks. Vectura's vision is to be an engineering firm worthy of high regard. Rejuvenating current container terminals through advanced automated designs, we operate towards the leading edge of technology, investing sufficiently in our people and equipment to ensure a high level of competence. Our innovative solutions, derived by our pioneering engineers, will utilise current operating terminals, improve safety and increase efficiency to give terminals a competitive edge while demonstrating corporate social responsibility. Meet the Vectura team. Programme Manager, Noor Rosley. Structural Engineer, Zaid Darwish. Systems Engineer, Stuart Campbell. Design Engineer, Yorios Karampatsos. Technical Project Manager, Oliver Stubbs. Before we chose our final location at Dibden Bay, we assessed other areas in Southampton for the port expansion. Berths 201 and 202, as well as Marchwood Military Port, were considered, but both were ultimately rejected in favour of Dibden Bay. This location will provide the required space in an advantageous position with no demolition works required, as well as already being part of the Port Strategic Land Reserve, making Dibden Bay the ideal location. Our vision for providing the future of container shipping for the Port of Southampton can be broken into several key deliverables. The 975,000 square metre site will receive sea freight from a 1,500 metre long quay, which will provide berths for up to 3 EEE class container ships, the largest in the world. This will be the only location within the Port of Southampton with these capabilities. Containers will be loaded and unloaded by 18 dock cranes. Freight will be transferred to and from the container stacks by a number of automated guided vehicles, or AGVs, which run on an electronic grid system to improve safety and efficiency. The terminal will have a practical static storage capacity of up to 33,000 TEUs, divided between 30 container stacks that run perpendicular to the quay. This allows a linear transfer of containers between the landside transfer area all the way through to the berth ships. Through the inclusion of buffer zones, delays to loading and unloading can be mitigated. Each zone can continue to operate independently of the next or previous stage. The landside transfer area allows trucks to deliver and pick up containers without interruption. There is space for several vehicles to park at once to avoid delays from turnaround times. The fully automated stacking area utilises 2 cranes per stack to position containers optimally 24/7. The waterside transfer area is serviced by fast straddle carriers that do not have to wait to pick up or deliver containers. Through automating all operations beyond the landside transfer area, a high level of safety and reliability is achieved. Rail freight will be catered for by an on-site rail network centred around a 6-track loading area serviced by 8 gantry cranes. While the cranes themselves will be automated, the transfer of containers to and from the rail freight loading area will be conducted by manned straddle carriers for safety reasons, as this will require transit through the landside transfer area. Therefore, autonomous and manned vehicles will remain segregated. The terminal also features a customs and excise facility with its own vehicle storage area and warehouse. Adjacent to this is a large secure warehouse for the temporary storage of sensitive cargo. Security, fire and safety services will also be situated in this area of the terminal. A chassis and HGV storage area is situated with easy access to the dock gate and landside transfer area. Port operations will be monitored from the Terminal Administration Building, the aesthetics of which have been designed to be reminiscent of a marine animal. This purpose-built, multi-role building will contain offices for site management, site engineers, logistics, finance, human resources and site maintenance divisions, over 10,000 square metres of floor space. The building has been configured to allow a large amount of natural light into the structure through extensive use of glazing, whilst the fins protruding at various levels are positioned to prevent direct sunlight from dazzling workers or overheating the office space. Additionally, the south-facing and downwards curving roof allows photovoltaic panels to be positioned at a more optimal angle to receive a maximum amount of solar energy. This intelligent building will also feature environmental controls over lighting, security and heat recovery systems to decrease the CO2 impact of its operation. The ground floor of the administration building will contain a large open reception and waiting area with a canteen situated at the tail end. Access to higher levels will be provided by elevator shafts and enclosed stairwells that provide lateral stability to the structure and a means of escape in case of fire. Office spaces radiate outwards from a large atrium at the centre of the building, which will allow large amounts of natural light into the structure through a steel lattice glazed roof. A plant room and building systems control room will also be situated on the ground floor. The first floor contains 3 large open-plan office spaces with conference rooms situated at the north-east end of the structure, as well as an archives room. Access between rooms is provided by walkways that cantilever out into the central atrium. The second floor will house the main operations control room and will offer a commanding view of the container stacks, landside transfer area and rail freight loading area to enable visual inspection of terminal operations. In addition, the second floor will also contain more office space and conference rooms. Vectura Solutions has also designed and produced software for the control of the containers stored in the Dibden Bay Container Terminal. The software is fully integrated with port operations and used to govern the actions of the automated machinery on site in conjunction with the client's needs. Through the intuitive user stage, the location and any relevant information for an individual container can be found, tracked, and used by both port operators and customers. The integration of the control system aims to improve port efficiency, increase productivity, and form the basis for a reliable container port. The control system is split into 2 different stages. Firstly, the operator stage, which comprises of the key coding and sort algorithms used to maintain the organisation of the automated container terminal, and is used to control the unloading, allocation, and storage of the containers depending on their mode and date of forward transportation, with priority stacking for the most urgent containers. The first stage also allows for customs to identify and track any containers they may wish to search and inform the customer through the user stage. The second stage is a graphical user interface that can be uploaded to the port operator's website to allow users to search for the location and relevant information regarding a specific container. The user interface comprises of a user login, ship selection, and container search page where individual containers can be found. A location is then provided along with a map to help locate the collection point. There is also an inquiries page to provide any further assistance. The completion of the project is separated into 2 phases. Phase 1 is the conceptualization and detailed design of all elements in the project, with 2 years allocated in the schedule to complete the design and planning process. Phase 2 is the construction phase, and this is split again into 3 stages. Stage 1 is expected to take 3 years to complete and comprises of the construction of Berth 1 and all port operation structures. This includes the construction of the administration building, utilities infrastructure, dredging, road network, rail network, port operations buildings such as customs and maintenance facilities, and integrated systems. In addition, the automated vehicles and cranes used in Berth 1 would also be required. Once completed, the port could begin operations on a limited scale using Berth 1 whilst work on Stage 2 can commence. Stages 2 and 3 are the extension of the terminal through the construction of berths 2 and 3 respectively, along with the acquisition and installation of all the associated equipment and infrastructure. The works for stages 2 and 3 is scheduled to take 18 months each for construction work and the handover process to allow the port to start using additional berths as soon as possible. If the schedule is kept to, the new automated container port will be completed in 8 years. By splitting the construction phase into 3 stages, the port can begin operations at a far earlier date. Through this, the initial investment required for the development of the terminal will begin to show returns before all construction works are fully completed, vastly reducing the payback time of the proposed project. The risk identification for Vectura Solutions was undertaken by analysing the potential risks associated with the initiation of the project, scheduling and procurement, design and operational activities. The assessment of the severity and likelihood was based on the Prince 2 Convention of Risk Management, and appropriate preventative actions have been suggested. Who will benefit from the project and how will it benefit them? Without Vectura Solutions, there will be no other automated container terminal to mitigate the problems of the already overcapacity Port of Southampton. This project will be the ideal platform for transporting freight via road, rail and sea. Once completed, this would drastically increase the through flow of imports and exports through the heart of the UK economy, as well as providing additional employment in the area. Vectura Solutions aims to provide a highly efficient and productive container terminal with minimal environmental impact while offering a high return on investment. Our policy of transparency through the involvement of interested parties from design through to completion provides investors with the trust they require to finance this project and be confident of an excellent return on their capital. Additionally, the collaborative involvement of organisations to bring this project to fruition provides an excellent opportunity to build lasting business connections and relationships. Lastly, being an automated port means minimal operational costs and decreases the turnaround times for containers. Hence, returns on investment will be realised sooner after completion. Construction Stage 1 has a predicted cost of £471 million, with Stages 2 and 3 costing less at £297 million, as some infrastructure such as the site rail network will already be complete. Within this figure, £12 million has been allocated for the administration building, £150 million for pre-construction costs, £20 million for site infrastructure, and £80 million for the port equipment such as dock cranes and AGVs. The overall cost of £1.07 billion includes a 20% contingency for any delays and unexpected events and an adjustment for inflation of 2% per annum. The income from the terminal is predicted to be 3 times the operational cost, with an increase of £120 million on completion of each additional berth. By adopting a 3-stage construction programme, the project is expected to break even approximately 11 years after breaking ground. Our overarching goal is to provide the Port of Southampton with not only the facilities to meet the projected need of 2030, but to future-proof the port against the ever-increasing demand for capacity. Our fully automated solution will offer a world-class service to port and shipping operators alike through efficiency, low overheads, and improved safety of terminal operations. Thank you for listening.